for lesson 203, we're going to be covering services. Again, this is kind of an overview, a broad sweeping overview, kind of gets you up to speed from things you might have talked about last year. So right off the bat here, the service drop is the overhead conductors between the service point and the utility electric supply system. Okay, and sort of the opposite side of that would be the service lateral, which is then the underground service conductors. So again, just to reverse here, we have service drop overhead. Service lateral is going to be underground, right? So next up, the service point is the point of connection between the local electric utility company, sometimes known as the point of demarcation, but in other words, where the building owner starts and the utility company ends. And you can see here, depending on the type of service, the service point on an overhead is going to be right here at the weatherhead. Down on the underground, you're going to see the service point can kind of change depending on the situation, but it could be at the utility transformer. It could actually be at the utility meter, depending. In this case, it's actually at in their instance, the pole-mounted transformer. That's not quite as common as far as what we see, but again, it's usually they're going to be at the transformer, or I think in most cases at the meter itself in our area. So your service equipment is all the equipment necessary to control the supply of electric power to a building. So in this case, they give us a panel board, a circuit breaker enclosure, service with a disconnect, and a load center, all of which have overcurrent protection, some type of main overcurrent protection. So additional services to a common building. Can we have more than one service to a building? In general, the answer is no, but there are some special circumstances and exceptions. So we can have a separate service. In fact, we have to have a separate service for a fire pump. They're showing us up on the top left. Separate service for emergency systems that, again, think of a generator there, right? Second service for multiple occupancy buildings. Big key there is we need to have total firewall separation. Two or more services for over 2,000 amps. Just a big service, big building. Multiple services for large area buildings. That's going to be the authority having jurisdiction. What's a large area building? That's a point of contention for sure. Multiple services for different characteristics. So in this case, we have some different voltages. Okay, and even that's fairly uncommon. We're usually going to have one service with a transformer, but it is something that can happen. And then underground services connected at the supply end, but not at the service end. So I've only seen this one time in my career, but we have one transformer basically feeding several main service disconnects here. All right, so service conductors may enter a building. Can a service conductor run through a building? Well, again, technically no, but they give us a couple examples here. In this case, we're actually running under the building. Technically, is that in the building? I would say not, but under minimum 2 inches of concrete, we can do that. That's no problem. That's kind of the main one that you're going to see here. In this case, maybe we don't have the concrete. They have 18 inches of earth for the example that they're giving us. But the biggest issue is those conductors, until they hit the main disconnecting point, are unfused. We can't have that in our building. So it's either got to hit the main disconnecting point and become fused, or we have to be under 2 inches concrete, under 18 inches of earth. A couple other exceptions there, right? So only service conductors shall be installed in service raceways. I think that's worth mentioning. I can't think of an example when you would want to put something other than service entrance conductors in with your service entrance conductors, but you can't do it. We get to some clearances, and this is kind of a big topic, a big deal if you don't get it right. But kind of the big number on if there's a window, a balcony, a ladder, you got to be at least 3 feet away, as shown in this diagram here, right? Service drops shall have a minimum vertical clearance of 8 foot above roofs. That's a flat or fairly flat roof, that is. We need to be at least 8 foot. Now, if we have a 12-4 pitch or a 412 pitch, that distance actually gets decreased back to our 3 foot. I guess they figure you're not going to have as much, people aren't going to be out on that roof as commonly, right? So if it's a 4-inch in 12-inch pitch, 3 foot is all the clearance we need, right? The clearance of overhead service conductors from final grade is based on their voltage and the type of traffic. So they give us kind of a rundown here, and you can see it runs anywhere from 24.5 feet all the way down to 10 feet. You guys can read through those and use your imagination, and it kind of makes pretty good sense. But again, depending on the type of traffic, depending on the voltage as well. The grounded conductor shall be no smaller than that required by 250.24c, which if we take a look at that here, it tells us where the AC system operating 1,000 volts or less, ground conductor shall be routed with the ungrounded conductors. A main bonding jumper shall be connected to the ground, so on and so forth. Essentially, what they tell us here is we need to size it according to table 250.102c1, which you can see similar to 250.66 is going to size it on the sides of the largest ungrounded conductor, right? So this is how we're going to size our system bonding jumper, main bonding jumper, those kind of things, right? 250.102c1. Minimum size for service entrance conductors is based on 230.79c and d, which here again for one family dwelling, the service disconnecting mean shall have a rating of not less than 100. For letter D, they tell us for all others, for all other installations, so non-dwellings, essentially the service disconnecting means shall have a rating of not less than 60 amps. So if it's a one family dwelling, 100 is as low as you can go. That's the one that always comes up. This D is kind of a special exception. Think of weird things, billboards, bus stops, things like that. 19 wiring methods are permitted for use as service entrance conductors. I'm not going to go through all these. You guys have a pretty good idea. We can be in various types of conduit. Naturally, we can have service entrance cable. There's about 5 or 6 of those that are common, but there are actually 19, which I found interesting. There was that many, right? So where practicable, the service head or gooseneck shall be installed above the point of attachment. So they call it service head or gooseneck. You hear weatherhead a lot of times. Where it's practical, I'm not sure if their word there, practicable, it's a word, but anyway, they want that to be above the point of attachment. Reason being, water is going to run down these wires. We have here what's known as a drip loop, right? That's why they want to see this above this attachment point. Water is going to run and drip down, and it's no harm of running inside that conductor, inside that conduit. The service disconnecting means shall consist of not more than 6 switches or circuit breakers. You hear that called 6 throws of the hand quite often, but essentially we need to shut the whole building down with no more than 6 throws of the hand, 6 breakers, 6 switches, whatever it is. Could be a main breaker that does the whole thing. It could be 6 individual disconnects. It could be 6 breakers in one enclosure. Whatever the case, 6 is your magic number there. Service entrance conductors shall be provided with overcurrent protection. Again, that's another big reason why we can't run those service entrance conductors inside the building before we hit our service entrance disconnect, because that's where we get our first means of overcurrent protection, right? So again, huge review there, kind of a recap, I like to think, of some things you guys already have. But again, there's a lot more to it. This was meant to be a kind of a brief rundown. So again, if you have any questions, as usual, feel free to reach out.